Hello, this is Mike at GameFromScratch, and welcome back to our ongoing MonoGame tutorial series. Today we're going to be looking at audio programming. Way back in the day in XNA, it started off that audio was all done using something called XACT. XACT stood for Cross-Platform Audio Creation Tool. And it's powerful. It allows you a nice way of splitting your audio out from the game itself so that your audio designers can configure it however they wish. Don't worry, we'll look at it in a little bit of detail later on. But it was also not the easiest way in the world to do things. And then over time, XNA started adding new functionality, simpler, streamlined interfaces for audio programming. And that is probably the primary way you are going to work with audio these days. Today we'll actually look at both ways of doing things, using the simplified modern API, and then we'll even look a little bit at using the XACT toolkit. Now, I'm not going to go too far into XACT itself because it is a complicated beast, but it does allow you to author and abstract away the audio part from your actual code. So you can do a lot of tweaking of these generated files and not have to touch code at all, which is nice. It's a nice layer of abstraction. So if you need advanced audio in your game, you should probably look at XACT. Now, there is a catch there. Those tools are not cross-platform. They are part of the Game Studio install or part of the DirectX SDK install. If you go to GameFromScratch.com, I do actually have a posting on how to install the XACT tools without having the requirement of an old version of Visual Studio being installed, which unfortunately is part of installing XNA. So anyways, let's move on. First, we're going to start with audio programming not using XACT. And let me just create a new project here. It's a Windows project. Sure, we'll put it there. And we will call this audio example. I'll do that twice over. Like so. All right, and let's turn on present mode so you can actually see what I'm doing. Present mode on. All right, get rid of him. Okay, so welcome to our code. We're going to have a couple of extra using exports that we haven't been using up till now. Every example so far that we've dealt with has either been already included in the graphics or the base class library or the input library, but the audio stuff is not. So first thing we're going to do is actually look at playing a song, and that is in the media library. So Microsoft.xna, XNA, can't type today. Framework.media. All right, so that's what you need for using the song class, which we're going to use pretty heavily in this example. And now we need a song, and we use the content pipeline for doing this, so we're just going to load this up right here. There is unfortunately a bit of a bug that a lot of times the content pipeline opens the previously loaded version. It's a known bug. Hopefully it's fixed by the time you read this, but as a neat workaround, just do a copy path of your content, double-click it, and here you're seeing it's loading an already opened content.mgcb file on us. So just go ahead and do an open and then paste in the path you just copied, and this will open the one from your actual project. Again, this is a known bug, and hopefully it will be fixed soon. So all we want to do is just like working with texture assets, except for here we're working with audio. We're just going to go ahead and do an add existing items, and I think this is on my desktop. I think. And it is prepare. Yeah. So we're going to go ahead and we're going to load an MP3 file here. And I suppose we should talk about that for a second. The auto formats supported are pretty much the ones you'd expect. There's MP3, OGG, WAV, or WAV, and then a couple other ones. WMA is a Windows Media Audio, some MP4 containers. So most of the files that you would expect can get brought into the pipeline. And as long as you're using the pipeline, if it works, that's good, because the pipeline will do the conversion for you, and you don't care past this point. There are a few things to be aware of, however. If you're not using the pipeline, then the format you're choosing is very important. For example, WMA is not supported on iOS or Android. MP3 is not supported on Windows Phone, I think. I don't want to be quoted on that. OGG is not supported on iOS, etc. So audio formats has always been a pain in the ass when it comes to game engine, and this is no exception. Fortunately, this is one of those things where the content pipeline tool does the work for you. So when you're picking the platform to build for, it will pick the right choice for you. Another thing to be aware of, if you're not already, is MP3 is a bit of a gotcha format. MP3 is ubiquitous, which is awesome. sort of. So pretty much everything supports MP3. It's a nice common baseline. Tools all support MP3 for the most part. MP3 players is what we actually call them. It's that ubiquitous. However, it's a patented covered format, and the patent holders have come out and said if you make or ship a product with over 5,000 users install base, you need to pay us licensing fees for your MP3. Now, I don't know how enforced this actual patent is, but just its existence should be enough to scare you off a bit. For the most part, I don't think games get stung for this. But in the world of patents as they exist today, I wouldn't take the risk. So if you can use something other than an MP3, you're probably in good stead. Now, generally what they would target with that kind of thing would actually be the tool developer. So if you made middleware with an MP3 component, you would be required to pay the licensing fee. Now, if you make an end-user game, it's questionable if this is going to apply to you or not. But it is a warning enough. If you don't want to expose yourself to this possible licensing problem for MP3 file, use something else. And this is why OGG Vorbis is a very nice alternative. Unfortunately, as I said earlier, it's not supported on iOS, so it's not a catch-all. But stick to the pipeline, and all of this stuff becomes relatively meaningless to you. So here you see, we've added our MP3 file. We could have just as easily set an OGG file in here. And the only real setting for the importer is going to be the quality to encode it at. You basically have a choice between fidelity and size. In this case, I'll just stick with best quality, and we're good to go. So this is going to bring in a song called prepare.mp3. And once again, the file extension is stripped off when we're done. So we're going to go ahead and do a build. So yes to save. Now we've built it, and we're good to go. So that's our imported to the content pipeline. Now we're just going to go ahead and use our song. So we added that media library earlier, and so that gives us access to song here. And I'm not actually going to cover it, but there's also song collection. So you can specify a number of them and go from track to track. So you can transition between songs, etc. I'm not actually covering that today, so just be aware that it exists. And we'll just go ahead and we'll do everything in load content, just like we did for graphics. And you're going to find it's very consistent. So we've got our song, and we will load it using the content class. So it's content manager dot load, and its type is song, and our file was called prepare.mp3. So just prepare like so. So this will load our song, and next up we just need to go ahead and play it. This is pretty simple. When we added the media framework, we also brought in a global instance called media player, static method called play, and we just pass in song, like so. And that's all that's involved in playing your song. That's it. Now, you can also, there's a couple of methods available on Media Player for, one is state change and one is track change, or something to that effect. It's slightly off. They're pretty equivalent. So media state changed and active song changed. I believe one has a bit more response to a few more things, like I think pause, resume, lock screens, etc. I'm not exactly 100% on what the difference between these two things is, but if you want to respond to either the song ending or the move next being called, you can respond to this one, or you can respond to everything by responding to this guy. And we'll just do a quick insert, and we'll have it fill in for us. And this is just going to be called when that song is done playing. And in our implementation, all we're going to do is we'll lower the volume of this song player dot volume, and volume goes from 0 is silent, 1 is full volume. So we'll just bring it down by 10%, and play our song again. And there's absolutely no reason for doing this other than to show you the existence of this event handler. But as you can see, you can easily have it handle, transitions when one song ends. You could queue into another, etc., and just handle it in this event. But as you see back here on this play, there was this also option to send in the song collection and then which song in the collection you wanted to play. So if you had like a 10-track soundtrack or whatever, you could handle it that way. But we're not going to. So let's go ahead and we'll just play this. Hopefully I didn't make that. Oops. Sorry about that. Basically, that will play until the end. Let me just. Ooh, I don't know if I can turn. Okay, sorry. I'm gonna bang you with loud music from now on because I don't know if I'm gonna mute my recording by changing any of that with a headset attached. So, From now on, I'm going to play as sound effects. I'm sorry about the volume of them, but there you can see that would play, and then when the song got to the end, it would have played again, just at 90% volume, then at 80% volume, 70, etc. So that's how simple playing music is. You bring in this media class here, you create an instance of a song, you load it using the content manager, just like you did for textures in the past, and then you use this mediaPlayer.play static function and just pass in your song. As you see, there's also a global level volume control for the media player, and there are these two events that you can track for when the songs actually end. So that's a song. Now we're going to take a look at sound effects. So instead of media here, we're going to want audio. So audio, like so. I'm just going to reduce, reuse, recycle here. So what we want now is a sound effect. How did I stay consistent? Oh, by the way, once again, I've done a text-based version of this tutorial. So if you go to GameFromScratch.com, search up for MonoGame audio, you can find the text version of this. I'll also link it below in the comments. And this time I'm actually going to use a collection of them. So we're going to need using system.collections.generic. I guess I should be more specific, but that'll work. All right. So now, instead of a sound effect, we're going to go and create a list of sound effects. We will call it sound effects. All right. So once again, we're going to do this in here. We'll get rid of all of this. I guess we should probably get rid of that method now. Okay. And you're going to find loading sound effects is a lot like loading everything else. First, I suppose in our initialize, or should we do it in the constructor? We'll do it in the constructor. We'll allocate our sound effects equals new list of sound effects. All right. And back to our content load. And simple enough, sound effects.add, and then content.load, and the type is sound effect. And then we pass in the name of the sound effects. And that leads me to something I haven't done yet. Actually, we can load the same one because we're actually going to be overwriting our existing. So we got to load up and bring in our sound effects here. Sound effects generally are single instance, and quite often we will use wave files to represent sound effects. So I'm just going to go ahead and I'll delete this guy out of here. And then we're going to add in our sound effects. So it's just a bunch of wave files. I believe they're in my downloads folder right now. Yeah. So I'll bring in airlock close, AK-47 shooting, ice cream, and sneeze. All of these I got from freesound.org. So if you're looking for sounds, it's a great source for them. And just say OK to everything. So now we've got these 4 sound files imported into our game. You'll see, once again, it uses the WAV importer this time instead of the MP3 importer, but you only have this one option of quality. And finally, let's do a rebuild on that. And okay, so we got our 4 items in. Now we can go back to our code and actually use them. So they were called airlock close. And it's time for some beautiful cut and paste coding. And then AK-47. And then ice cream. And then sneeze. Now let me just bring up the mixer here. Maybe I can make the sound so it's a little bit... okay, this isn't my volume mixer. Alright, so my recording should stay at full volume. No, that's going to bring everything down. Alright, I may blow your brains out again by playing this. I may not. We'll see. Sorry if it comes out extremely loud again. So we've loaded in our 4 different sound effects, and we're just going to go ahead and we'll play the first one just to see that everything works. 0. And playing a sound effect is as simple as calling platform initialize. That was wrong. Alright, play. So this will load our 4 sound effects into our list. We'll play the very first item in the list. And next up, very key concept here is instances versus sound effect. So we have four sound effect objects, and a sound effect is perfectly usable. It's a fire and forget instance. So basically, you got a sound effect, and you can play it and stop it, and that's it. And there's only one of them. Now, a lot of times you're going to have a sound effect, and you're going to want to have multiples playing at the same time. For example, a gun, you could shoot this AK-47 30 times or just once. When you use sound effect itself .play, like right here, there's only one. So I play it again. Actually, no, it will support multiples, but it's using I'm using a really bad definition. It's using the root instance. Now, what you've got is if you want to have multiple, if you want to control them after the fact, for example, if you want to have looping or change the volume, or you want to apply some special effects to it, like we will later on for adding some 3D positioning, etc. In that case, you need to use an instance. But don't worry, an instance is very, very simple. Now, one of the big things about an instance is it's a super lightweight class. An instance, all instances share the same data, the same memory buffer from the root sound effect. So you can create 30 instances of a single wave, but they all have just one chunk of waveform data. So all that the instance has is like the specific details to it, its volume, its current tracking position, etc. So it's a lightweight class. You can create a bunch of them. Now, when I say a bunch of them, it depends on your platform. These numbers are iffy. I haven't tested them all. They're from various different sources. But I believe if you are, for some reason, targeting an ancient Zune device, you're limited to 16 audio instances. On Windows Phone, it's 64 instances, concurrent instances. On the Xbox 360, it's 300. And on the Windows PC, at least under the XNA's implementation, it was unlimited. Now, obviously, you can't play unlimited concurrent sounds. You are eventually going to hit some kind of a hard limit from the driver or the sound card or whatever. But XNA is not limiting you at this point. I do not know if MonoGame imposed any additional limitations on top, but for the most part, you can play as many sounds as you need if you're dealing with a platform like a console or a desktop. So, as I said earlier, you can play a sound effect off of the root instance this way, or you can create an actual instance like this. Did I already put an enter? Yes, I did. Okay, so we want to create an instance. Var instance equals sound effect set. Same one. Create instance like so. And like I said earlier, if you want to have additional control of your instance, like for example looping it, you can't do that with a sound effect, but you can do it with an instance. So let's just look at that now. Instance dot is disposed is looped equals true. I'm just going to go ahead and we'll mute that guy out. And finally, let's play the instance. And we'll start this guy off now. And I will hopefully be able to manage. There. Hopefully that applies and stays applied. So there is that sound effect, just looping over and over and over again. Now let's take a look at adding and using those other sound effects we've got. And we're just going to do that. We're going to handle that in the input. So as you press the number keys, we'll play the different sounds. And we'll be using instances every time, so you can have as many instances of a particular sound playing at a time as you want. And that is right about where we're going to go. So if keyboard.getState.is key down and keys.d1. Not sure what the D stands for, but that's your one key anyways. Sound effects at 0. Create instance. Play. Let's just do a cut and paste coding. So this is a 2. This is a 3, this is a 4, this is a 1, this is a 2, and this is a 3. Now what we also might want to do is get all of our currently playing sounds and mute them. So let's just add one more logic handler in here. So keyboard.getState.is key down keys.space. So you hit the space bar. We will either mute or unmute depending on our current volume status. So that is if, and you notice we're using the sound effect, we're using a static member of the sound effect class here, master volume equals, so this is going to be the volume of all playing sound effects, not just an instance. So the instance actually has a volume as well, but we're doing it for all sound effects, of all sound effect, not a single class, not a single sound effect instance, but all sound effect classes, if that makes sense. So if it is currently muted, we will set it to full volume, like so. And let's keep our Fs going. Otherwise, set it to no volume, like so. And that in theory should work. Let's go ahead and play it. So we've still got our first sound looping in the background as I press the 2 key, our AK-47. Let me just go back over here. Hey, why did you not keep? And then our, what else we got? So AK-47, oops, focus. Ice cream truck, sneeze, and spacebar mutes it all, and spacebar unmutes it, and that's about it. So that's playing sound effects. Quite a simple process, not a lot to it. All right, so now let's move on. Now, remember earlier when I said that you could apply positional special effects to something? Let's go ahead and do that now. I'm just going to get rid of all of this again. Once again, I'm doing a lot of recycling in this version. If you need the code examples, they are available. GameFromScratch.com, the text equivalent, has the exact same code that we're going through right here. So all the sources available on GameFromScratch. Look in the comments below for a link to that page. I'll get rid of all these guys. It's just easier than me creating a new project every time. And finally, we get rid of our list. And we're just going to use a single sound effect this time. So, okay. Now, we already have our audio up here. Guess we technically don't need you anymore. So no changes needed there. And we no longer need to allocate our list. And on down to load content. And what we need to do is create, sorry, I forgot. We're going to use a couple of really key new classes up here. And we're going to be using sound effect. Here, let's track our sound effect instance too. Because you need an instance in order to apply special effects to it. So we'll grab that guy, and we're going to create two new classes, an audio listener and an audio emitter. We're actually only going to be using one of these in this example, but the listener is your location of your virtual ear in the world, where the audio emitter is the sound source. So you can position sound, and you can position your ear. But we're actually going to leave, what do I end up moving here? I move around the ear. So the audio listener is going to move, but the audio is going to stay at the origin. So that's what these two, they go together. This is your position of your virtual hearer or your virtual ear in the world, and this is your virtual sound source. So you could ultimately have a bunch of different emitters, but a single listener. You can have multiple listeners too, of course, but in a typical game, that's not going to happen. So now we got to load our content in, and this is, I'll just load our listeners in here too. Equals new audio listener, and emitter equals new audio emitter. That was it. All right, so that went away. All right, perfect. So now we're going to go ahead and, I should have loaded my sound effect. Okay, sound effect equals content.load sound effect, like so, and we will load our circus sound, which I guess I need to add. Now, there's something very important to this step that you should be aware of. When you're doing positioning of 3D sounds, your sound effect itself needs to be in mono format. So what we are adding here, hopefully it's from down, where the hell did I put it? Is it desktop? lost this sound. Let me get it from my master instance. Sorry about the delay here. Are we on the one example? I think this is 3. In Windows, debug. Oh, content. Oh, it's an XMP file there. Shit. 1 sec. It should be here. Okay, so there we go. So here's the WAV file we're going to use. And the key thing, hopefully it shows you here if I go in. It doesn't. Why don't you show me this information? Damn it. It needs to be in mono format. That's a big catch, is that file, if it's a stereo, so if it's got 2 channels, one for the left and one for right audio, it will not work in 3D. You gotta make sure that your audio file is mono. It's easy enough. Use the program Audacity, completely free. You could strip out the extra channel if you wish. But this file, whatever you bring in, has to be in mono format, or it will throw an exception when you do an apply 3D call. So, sorry about the delay there. I sort of lost my original source. And now that we have our sound effect, let's go ahead and create an instance of it. We're going to loop that same instance forever. So, sound, what was that? Sound effect instance equals sound effect create instance, like so. Sound effect instance dot is looped equals true. All right, so we're gonna load our sound effect, create an instance of it, and loop that instance forever. Create our audio listener and audio emitter. By default, they will be at the vector 0, 0, and 0, unless you specify otherwise, and that's fine for us. So basically, our ear is going to start at the origin, and our sound source is going to start at the origin. Not a big deal. So let's go ahead and apply those 2 things. So audio effect, sound effect instance dot apply 3D, and we pass in our audio listener and our, what's the other one? Audio emitter, like so. So this is applying the 3D transformations to that sound based off the position. In this case, they're both at 0 and 0, so it's probably actually doing nothing. And finally, let's go ahead and play our song. Okay, so I'll run this quickly and you'll see what I mean. So there's our sound playing as normal, and it will loop forever constantly. So now what we want to do is actually move that position around when we press keys. I did a whole lot more typing in the other example, so I can move up and down, left and right, but I'm just going to make it left and right for now. So, again, if keyboard.get state is key down, and we will use keys.left for the left arrow, end of our if. Open our squiggly brace, and we will go listen audio listener dot position. So here's that vector 3 representing the position of it. Now that's a struct, so we're going to have to create a new one and assign it. So new vector 3, and we're going to use the old one's position. So audio listener dot position dot x minus 0.1 f. So we're going to move by 0.1 f along the x. And now we need to go ahead and, if I screwed this up, no, I don't think so. Audio listener dot position dot y is unchanged, and audio listener dot position dot z is unchanged. New is done. Close that off. I probably made a typo there, but good enough for me. And now once you've actually updated the position, you also need to call apply 3D again. So we just go audio, okay, so no, sound effect instance dot apply 3D, and we pass in our audio listener and our audio emitter again, like so. And joy of copy and paste coding. Let's grab that guy. and do it for the right key. Exact same logic. We're just going to do plus instead. Now, at the same time, you could obviously do this for the Y and the Z axis, and you'll have the same effect. But I'll just do left and right. So again, the example on GameFromScratch.com is a little bit more complete. I just don't want you to watch me type all that stuff over and over and over again. And I think that's about it. So if I haven't screwed this up, let's go ahead and run it. So there's our sound playing. I'm going to hit the left arrow key, and you'll hear it shifted the one way. Now I'm going to start hitting the right, and we'll come back towards the center, and now we keep going right. As you see, and I'll just keep hitting right, and it'll get quieter and quieter in your left channel only. Now, if you're not listening to this in stereo, this example is not really helping you at all, but if you have it in proper stereo, you should be hearing the effect of panning left and right as I'm moving again to the left, and now too far to the left. So you can easily position audio using the apply 3D method here. Just pass in a listener, pass in the emitter, and then change the positions according to your world. That's it. So that's positional audio in XNA. Next, we're going to go back to the XACT tool I was talking about earlier. Now, the XACT tool is part of the XNA install or the DirectX install. If you go to GameFromScratch, I do have instructions on how to install it without having to have an old version of Visual Studio around. So if you want to just install the XACT tools, you can. They will install, and it all depends on if you're 32 or 64-bit Windows. You're probably 64 at this point, so they will be installed into the program files x86 under Microsoft XNA, XNA Game Studio 4.0, Tools, and there's a pair of files here. There's XACT 3, which is the tool we want, and Audio Console 3, or Odd Console 3, which the XACT tools depend on. So first thing, just fire this guy up, and it runs here in the background for you, and that's it. So now run your XACT. And I'm only going to really briefly touch on XACT. XACT is a full-time job in itself. It's for your audio engineer, if you want to give yourself a very fancy title, so that they can configure sound effects externally to your game. And they've got a lot of control over it. You can do Doppler pitch, cueing, da-da-da-da-da. They can change the properties on the sound. We'll see it very shortly. But this gives you a lot of control over the particulars of the sound. But in a way that you're going to just generate 3 files as output. And then in the actual game engine, you don't have to do anything. You basically can just do a single line of code to play stuff once it's initialized. So this is for abstracting your audio settings outside of your game. So first thing we're going to do now is create a new project. Just click this little icon right here. It's going to ask you where you want it to be. Here, let's just create a new folder called Audio 2, like so. And open that up, and audio 2. So this creates a ZAP file, XAP. You don't actually do anything with it, but if you're going to open it back up in here, that's where it comes from. The first thing we do is do a wave bank, and this is your source audio. I guess you could think of it that way. Just right-click it and do a new wave bank, and this opens up this little window here. And now we can just bring in the files we want to use. So let me just close this guy back down. Are they here? No, they're under my downloads. All right. First, bring in whatever audio files, MP3, OGG, whatever you're actually going to be using here. Oh, damn, there's Circus all along. So I guess it wasn't as lost as I thought. Here, I'll just bring in Sneeze, Ice Cream, and AK-47, and Airlock Close. So you bring those in and drop them into your wave banks. You can have multiple wave banks, and you see down here you've got a couple of settings you'll use for it, but not too many. You can decide if it's going to be in memory or streamed. So like I said, you're bringing the controls or the settings of how you're going to use these files, but you're bringing it external to your code. So that was created a wave bank. Now we're going to create a sound bank. Same process, right click and new. And now you just decide what waves you want in the sound. We're just going to use our gun, for example. So we'll bring AK-47 and just drop it into your sound bank like so. And now you'll notice there's a couple more things you can set. The volume, the pitch, the priority, how many times it'll loop. You can do high pass, low pass filters on it, the volume controls, etc. So you can configure all of your various settings for your audios in this tool here. And finally, now that you've got sounds in your sound bank, you can go ahead and drop it into a queue. And a queue is what your programmer is ultimately going to use inside of your XNA game. You can rename it right here. Let me just see in my source example what I did. Just keep my code example. No, I went with AK-47. So your queue itself, you can have multiple. So I could drop in 2 sounds and give each one a 50-50 or a 90-30, or sorry, 90-10 probability of playing. Uh, you can set the weighting of the probability between different sounds. So you could say have like a soundtrack with 10% chance of playing a particular sound or whatever. So you can do multiples with the same name. So I call it AK-47, and then it randomly does whatever probability to figure out which sound effect to play when I say, go ahead and play me the AK-47 sound. And generally, like I said, you would use that more for a soundtrack type thing. But this is a very simple, and you can also set the instance. So you can say, I can only have one instance of this ever playing, and then you can set some properties on it as well. So this is a very simple version of an audio project, but that is it. So basically, bring in your source files, create a sound bank from it, take your sound bank and create a queue from it. Whatever other settings, audio settings you're going to want, you can explore those at your own. Obviously, there's a lot more to this than I'm showing you. But when you're done, just go ahead and do a build. So now we go back to the directory. So that was under c:/temp/audio2. You'll notice it created 2 folders, Win and Xbox. Now, there's a very important thing to know about here. You are going outside of the mono content pipeline here. This tool is not going to take care of the platform specifics for you. So if you have file format incompatibilities with different platforms, have fun. So you are to bring in the power of XACT, and then this kind of flexibility, you might have to do some more data massaging on your end to make it work on all of your different supported platforms. This is completely outside of the content pipeline. In fact, we can't even use the content pipeline for bringing these assets in. We're going to have to bring them in ourselves. But you'll notice it created 2 folders here, one for the Windows, one for the Xbox. We'll just go ahead and take the Windows version, and it creates these 3 different files. An XGS, which is the overall settings for our audio engine, our sound bank, and our wave bank. And we're going to want these 3 files in our project. And I don't remember if I can get away with drag and drop on this one, but let's give it a shot. So we'll bring them into our content folder like so, and then we want to take each one of those files and make sure that its build property is set to either copy or copy of newer. Copy of newer should work fine. So those files will automatically be copied in this particular directory. So now you go away and back to our project. So now we brought in those 3 files. Now let's go ahead and use them. Get rid of all the stuff we did in the previous example. And we don't need any of this anymore. Like so, and we no longer need any of these guys. The process of using all those guys is pretty simple, but the key thing is you're not using the content pipeline again. You are bringing them in and dropping them into your content folder manually, and make sure that they're set to copy so they end up being copied into your bin/content folder, and they're available to you. So now that that's done, let's use them all. So we're going to need a couple of things for this example. We are going to need an audio engine. We shall call you audio engine. We are going to need a sound bank. And we're not technically going to need a wave bank, but we'll load it anyways. Okay, so those are the 3 files we just created. And now let's use them all. We'll stick in load content just to be consistent. So first we create our audio engine. Oops, one too many enters. And the audio engine is as simple as new audio engine, and you pass in the path to that file. So content dot you can pin for a minute. So content/audio2.xgs. And then we want our sound bank equals new sound bank, and it is content slash sound bank dot xsb and terminate. And wave bank equals new. Apparently I did something wrong on the last call. Wave. Oh yeah. My bad. I did this when I wrote it the first time too. You got to pass in your audio engine. That's the first parameter. Audio engine. So essentially what you're doing again is you're putting your audio logic, your audio configuration, your sound effects, all that stuff into external files, and then you're just loading them this way. And so it's a very handy setup, but it does require you to jump through extra hoops. And you're kind of getting away from the advantages of the content pipeline at that point. So you are going to, if you're creating a Windows-only game, for example, you've got no issue with using this. It's very easily supported, wavebank.xwb. But if you are doing some of the cross-platform stuff, you are going to run into situations where the output from this, the files that are used, might not necessarily be compatible with the platform that you're trying to support. So finally, now that we've done all of this, so we've set up our audio engine from loading this file, and then we created a wave bank and a sound bank. Finally, we want to use it somewhere in our game, and we're just going to go ahead and play a sound. And this is very, very simple. From our sound bank, we just play, if we get our cue that we created earlier, so remember back here, we created a cue called AK-47. Its name is set configurable right here, but we didn't change it, so it's called AK-47. So we just get the cue by name, AK-47, like so, and we can use that cue just like any other audio. So let's go ahead and play it. So now I'll just go ahead and run this, and boom. So what we've done there is we've taken our audio logic and made it configurable using this external XACT tool, which has a ton of settings that I don't particularly understand, but this allows you to take your audio from your game, and basically an audio engineer can now create all this stuff and configure all the settings for you, and you just use it by name. And loading those files is as simple as this. So that's some pretty powerful stuff. So the exact stuff, if that's a road you want to go down, it is definitely available to you. But just you may run into some cross-platform specific issues. So even though it allows you to nicely abstract your audio out from your code, it may not be worth it. Now there's one last thing that we're going to cover. Very simple thing actually, but kind of important. So far everything we've done has required a content pipeline of sorts. In this case, we're using XACT. XACT is generating these database files essentially for us that we're loading in with this code you're just seeing. Earlier we used the content pipeline, and then we were loading our assets in using content.load. However, what happens if you want to load your files in, say, locally, or you had them, you gave the user the ability to download files into a folder, or you want to use their own songs and you want to load them off a local path? You can, and it's quite simple actually, with one really big caveat. And first things first, we are going to need, actually we're going to need to just basically get rid of all of this. And I'm going to load a song here, so we're going to need media back. So we'll use media instead of audio. And this will nicely tell me what I need to delete, because I got rid of audio. So all of those gone, and so we're going to create, you know what, I'm going to do it all locally. So we go down here, and we don't need any of this anymore. So in this case, we are not using content pipeline at all. We are going to load it from a local file in our content folder. Now, of course, we're going to need a local file in our content folder, so let's go ahead and get one. I should still have an MP3 on my desktop. So we'll bring it in and drop it to our content. Why is it prepare already exists? Yeah, sure. And let's go ahead and make sure that it gets set to copy or copy if newer. Yeah, we'll copy it every time. So this could be anywhere. It didn't have to be in our content folder, but it's easy enough because it's already set up to go there. So now we're going to look at loading a file directly. And this now is going to use the URI. So first we go system.uri, which is a URL. URI equals new system.uri content, and it is called prepare. Now in this case though, we do need the file extension. Very important there. And this is another gotcha. This is a MonoGame gotcha versus an XNA gotcha. The path of this URI, okay, where is, what's it called again? System.uri kind needs to be relative. And this sucks because if you're working on XNA only, not MonoGame, but XNA, you can pass in HTTP : and give it a network address, and it will grab it. In this case, it has to be relative to your project root, which is unfortunate. So if you need to do a download of a file, you would have to download it first to somewhere on your local machine or on the game's directory hierarchy somewhere and open it that way. So you unfortunately cannot use an absolute URL for accessing um, assets the way we are about to, which is a bit unfortunate, but not a deal breaker. There are other ways around it. So next up, we're going to go ahead and create a song equals, and then we use from URI, like so. And all we do is pass in the name of our song, we'll go with my song, and our URI. So we just loaded our song using the URI we just passed in. And finally, media player, same logic, dot play song, like so. And play that. There you see, it's loaded up our song, and off it goes. So as you can see, you can run local files that don't get processed through the pipeline. You can still load them in using this from URI format. So this does not depend on the content pipeline, and this does not depend on XACT in any way whatsoever. So the biggest reason why I think you would go this route is if you wanted to have the user be able to create their own sound effects or, soundtrack or whatever. This is an approach you can take. You are going to run into issues of getting permissions, etc. It's going to be a bit of a headache. But if you do need to load resources outside of the content pipeline or outside of XACT, you can do so using URI, as long as your URI is relative. So that's basically it. So today we looked at audio programming with MonoGame, including, let's see, we started with playing songs, and then we looked at sound effects, create instance to create concurrent sound effects. Then we looked at something else I'm not remembering right now. We looked at generating your sounds externally using XACT, so you can keep your configurations, etc., outside of the actual game itself. And then finally, we looked at loading dynamically using URIs. That's about it. So that is pretty much all that you need to know about audio programming in XNA or MonoGame. There's a bit more, obviously you can pan your audio, you can change the sound as you go, you can do queuing systems. We saw briefly there's the sound collection for creating basically soundtracks, and then there's methods in there like move next, move previous, so you could do VCR style controls for controlling your sound effect, or you can do it in code, etc. But there are a couple events that you can also queue up to very easily create your own soundtrack manager. But that's it. Sound in XNA is quite straightforward. You want to stick to the content pipeline when you can, because that will take, if you're working cross-platform at least, because that will take away the platform issues that you might run into. But if you don't, you can use XACT to have a bit more control and take the actual configuration completely outside of your code. So you can hand off audio to someone completely different, and they just generate these 3 files or multiple versions of sound banks and wave banks, I suppose, and you just dump them in your project, and you're just working with them using a key or a key. So it's a nice way of abstracting away the logic, but you will run into platform-specific issues if you go down that road. And then finally, you can, of course, load things directly from file via the system.uri and passing in a relative path. Hope that was useful. Thank you very much. Goodbye.